Algebra 1. Fun Sock Friday, the 4th. Okay? We'll do that later. Okay? SWBA students will be able to solve equations by addition and subtraction, section 2.2. Okay? We're going to talk about solving equations by addition and subtraction. Good place to start off. Okay? Might be writing your name in that top right corner if you haven't already. Okay? So I'm going to write Mr. Castle. Okay? Me llamo Señor Castle. Okay? En español for those of you taking Spanish 1. Okay? All right. Okay? Profe Castle, if you will. Okay? Or Señor Castle. Either one. Okay? Right? Okay? Now, let me fix this kind of sliding down a bit. Where'd it go? There it is. Alrighty. So, let's work on solving using addition. Suppose any algebra class, okay, suppose my Algebra 1 class has 25 students. We don't have 25 students right now. Suppose an Algebra 2 class has 25 students. Each class adds 2 new students. The number of students in my class would still be equal, wouldn't they?
True.
How much would each class have?
27.
27, okay. Now, would they still be equal if only one of the classes added 2 students? No, okay. And the reason why is, let's say, like, okay, I took 25, and that was equal to 25 originally, okay? 25 was equal to 25, okay? Then what I did, okay, I'll draw an arrow. Then what I did, okay, was I added 2 to both of those. So I took 25 plus 2, and I said, okay, that's going to be the same as 25 plus 2. So I add 2 to both classes. So then I still ended up with 27 is 27. Does that make sense? Yeah. Okay, we're tracking with me? Okay. This example illustrates what we call the addition property of equality. The addition property of equality. This illustrates that. It kind of shows it. Now, we have in this box, the same kind of box we used for our other properties last chapter, okay, that the addition property of equality, if an equation is true, so you have to start off with a true equation, like 25 equals 25, that is true, okay? So if an equation is true, and the same number is added to both sides, each side of the equation, the resulting equation is still true. So you start off with a true equation, you add the same thing to both sides, you'll still end up with a true equation, okay? In symbols, okay, for any numbers A, B, and C, if A is already equal to B, so we start out with a true equation. 2 numbers are equal. A and B are 2 different numbers that are equal. Then, A plus C is going to be equal to B plus C. If I take the A and the B, and I just add C to both of them, it's still going to be true. That's the same thing as 25 plus 2 and 25 plus 2. Okay, we're just saying 2 numbers, A and B, are equal to each other, so they have to be the same number. And if I add the same C to both sides, add the same C to both sides, same number to both sides, it's still going to be true. Okay? Josh, give me a number. 32? 32. So 32 equals 32. Is that correct?
Yeah.
That's a true equation, right? Okay. Brady, give me another number.
46.
46, okay. If I take 32 and add 46, and I do it to both sides of the equation, do you think I'm still going to get a true equation? I think so, okay. That's what the addition property of equality says. 32 plus 46, what is that? 78. 78 is equal to 78. Yeah, it's still a true equation. Okay, it stayed true. Questions on that? Okay, that kind of just makes sense, doesn't it? Okay, as long as we do the same thing to both sides. But would it work if I just added 46 to one side of the equation? No, then I'd have 78 equals 32, and that's just not true. So we have to add it to both sides, okay? Now, we have this little bullets beneath them, okay? So equivalent is the first word, equivalent equations. Equivalent equations have the same solution. So if 2 equations are considered equivalent, they have the same equations. They have the same solution. Now we're going to work on solving equations, okay? To solve an equation, it means to find all values of the variable that make the equation a true statement. we'll find all values of a variable that make the equation a true statement. We'll say, hey, this equation is true when the variable equals blank. And it's the Apple Pencil. And we do this by isolating the variable. Does that blank need to be made longer? Okay. What does isolate mean? What's isolate mean? Okay, keeping kinda. Okay, Jaden. Take away from everything. Take away from everything else. I like that. Okay, you're getting it by itself. Okay, you're putting it by itself, whatever it is. Ladies. Okay. So we do this by isolating the variable, getting it on one side by itself with a coefficient of 1. Okay, no other coefficient besides 1. So it's not 3 times the variable, not 2 times the variable, it's 1 times the variable. Which basically, if it's 1 times something, do you even have to write 1 times it? No. Because it's the same thing. We learned that last chapter with the multiplicative identity. 1 times anything is itself. Okay, continuing on. So these examples, we have these equations, okay? Number 1, r minus 8 equals 32. r minus 8 equals 32. We have a variable here. We have an equation. Okay, what variable do we have in number 1? R. What's happening with r? Subtracted, okay? So we want to get r by itself, okay? So we say we want to get r by itself. So we have to undo what's happening with it. We have to undo that. So we have to undo subtraction. How do we undo subtraction? You add. Yeah, you add, and we have to add 8 to both sides. Why are you choosing 8?
Because it's being subtracted. It's because you want it to be 0. It's one.
Yeah, you want it to be 0. We're going to choose whatever number is being subtracted because negative 8 plus 8 is 0. Do I have to write r plus 0? No. I can just write r. And now I can write equals and then say, okay, well, on the right side, what happened? What's 32 plus 8? 40. So r equals 40. And those 8s, they end up zeroing out. We learned about that, the additive inverse, right? Any number plus its opposite. So negative 8 plus its opposite, positive 8, would give 0. So r is 40. Is the variable by itself? Yeah, so we solved our equation. This equation is true when r is 40. Would the equation be true when r is 5? No, because 5 minus 8 would not equal 32. Now it says check your solution. Do you guys know how we check our solution? Okay, Abby?
You replace the variable with 40.
Yeah, you replace the variable with the 40. Does anyone know the fancy math term for that by chance? Replacing the variable with the number. Okay? Okay, hey Emily, say that louder. Substitution. You substitute it in. Have you guys ever heard of a substitute, like maybe in sports? Okay? A substitute comes in and they play the same role that person they took out did, right? A substitute comes in and plays the same role, right? Unless you move people around. They come in and play the same role. So like in football, for example, okay? Varsity has a game tonight. Freshmen had a game yesterday, okay? So let's say in football, okay? There's an offensive lineman, okay? One of the big dudes blocking, okay? Big dude blocking other big dudes. Okay? You're not going to send in a small wide receiver in to block as an O-lineman. You're not going to substitute a wide receiver for an O-lineman. Not going to do that, okay? You're going to substitute an offensive lineman for an offensive lineman, okay? Volleyball. You're not going to sub in an outside hitter to play libero, okay? Softball. You're not going to sub in maybe your left fielder, okay, to play catcher. Okay, you're probably not going to do it, right? Like, you get some laughs, you're like, no, you're not going to do that, okay? Same idea, okay? Band, okay? You're not going to take someone from the trumpet section and put them in the pit and play the marimba. Not going to work out too well, more than likely, okay? Unless they're also skilled in that, okay? All sorts of examples here. Cross country, it's a little bit tougher with that with cross country, but I can't think of one there. But anyway, so we're going to substitute in for what's there. Okay, so we're going to take this r equals 40, and we're going to rewrite this equation and put 40 minus 8 equals 32. Now I say that we're asking a question here. we're asking a question here. We're asking, does it equal? We're checking this to make sure it works. So I'm going to put a little question mark, and I kind of went over my over the equal sign. I'm going to put a question mark over it because I'm saying, does it equal? Okay, you guys know how when you ask a question, your voice kind of goes up at the end, and it's called inflection? You guys know what I'm talking about? Like, hey, where are you going? Like, you kind of just naturally go up a little bit at the end. Okay, it's not like a ton necessarily, but like people just kind of do it naturally, especially in the English language and in American culture. So I like to joke around. It's like 40 minus 8 equals 32, and just make a joke out of it. Okay, so 40 minus 8 equals 32. Well, let's check it. What is 40 minus 8?
32.
32. So does 32 equal 32?
Yeah.
Yep, we checked it and it works. Okay, if we plugged a different number in there, it wouldn't work, so we know we got it wrong. Nice thing with math, especially with algebra, I love this. You can know if you got it right away. You can know right away if you got it right or wrong. Okay, so on a test, on homework, you guys can check your solution. It takes a little bit extra time. But you can know right away if you got it right. All right, let's move on to number 2. H minus 12 equals negative 27. H minus 12 equals negative 27. My big question on these all the time is what's happening with our variable? What's happening with our variable right now? So we're subtracting, okay? How do we undo that? Add 12. We chose 12 this time because that's the number we're subtracting by. Negative 12 plus 12. That gives us 0. So we're just left with H on that side. We don't even have to write plus 0. We're just left with H. We effectively moved the 12, so to speak. We moved the 12 to the other side of the equation, so to speak. Now, negative 27 plus 12. 15. Negative 15. We have to be careful there, okay? Be careful there. Okay, a good way to remember that if we might get tripped up with our signs, okay? There's a song here for it. You guys ready to have blood coming out your ears from my bad singing? Okay? Same sign, add and keep. Different sign, subtract. Keep the sign of the bigger number. Now you'll be exact. Okay? To the tune of row, row, row your boat. Okay? I'm not a singer. My wife is. Okay? So, same signs. If two numbers have the same signs, like on number 1, 32 and 8, those are both positive. They have the same signs. Also works with two negatives. You add the two numbers and you keep whatever sign you had. So in this case, 32 plus 8 is 40. They're both positive. You stay positive. Okay? If there are two negatives, you'd add them and you keep the negative. Different signs, negative and a positive, you subtract the two numbers. You do biggest minus the smaller. So in this case, 27 minus 15, you get, or 27 minus 12, you get 15. But you keep the sign of whichever number is bigger. Okay? And you get a negative because 27 is bigger than 15. Or 27 is bigger than 12. I keep saying 15. We end up with a negative. So if signs are something you struggle with addition and subtraction, okay, adding them together, you struggle with the signs on that, and what to do when, that song can be handy, okay? If not, well, sorry. Can I sing it again? Oof. Okay? All right. Okay. If anyone wants to sing with me, you're welcome to, okay? Okay. Same sign, add and keep. Different sign, subtract. Keep the sign of the bigger number. Now you'll be exact. Yep, I know, it's terrible. It's terrible. Don't at me, okay? So, other Abby, okay? We're going to plug it in just to check our answer, okay? Negative 15 minus 12 equals negative 27. Well, if we take negative 15 minus 12, those are the same signs, two negatives, so we'll add them and keep the sign. So add 15 and 12 and we get 27. Stays negative. Negative 27 does in fact equal negative 27. I put a check because it checked out. I put a check because it checked out there.
I feel like you write way faster with the thing.
I definitely do.
Like I look down for one moment and then like it's a whole new thing on the board.
It's like a whole new world.
I like it.
There you go. Okay. Dazzling place you never knew. Okay. On number 3. Be careful. This is not 3.5. This is just 5. Okay. It's not 3.5. It's 5. Okay. Yep. I knew that tripped someone up. Okay. 3. 5 is equal to x minus 10. 5 is equal to x minus 10. I want you guys to do that on your own. When you have it or have questions, raise that hand of yours. Anyway, 5 is equal to x minus 10. Okay. Jaden, what did you do?
I added 10 to 5 and I added 10 to 10.
Yep. And you got 15 is equal to x, and those negative 10 and 10 zero out. So you have 15 equals x. Okay? So be careful. We have to move the 10 across even though we're going from the right to the left now rather than left to the right. We still move whatever's with the variable, okay? So we can go back and check our work if we would like as well. 5 equals, okay, 15 minus 10. And then 15 minus 10 is 5. So, yep, it checks out. Okay, questions on that one at all? Dope. Okay, let's continue on. Now we're going to solve using subtraction, When isolating the variable, it doesn't matter if the variable is on the left or right side. We don't care if the variable is on the left or right side. The equation is the same either way, okay? So whether or not you have 15 equals x or x equals 15, they're the same exact thing. We don't care. That make sense? Awesome. Okay.
I wrote it in the wrong box.
Oof, okay. So, solve using subtraction. So, similar to the addition property of equality, we have the subtraction property of equality. And it can be used to solve equations too. So, subtraction property of equality, if an equation is true and the same number is subtracted from each side, the resulting equation is true. Is that basically the same as the addition property, except for now it's just subtraction instead of addition? Totally. It's word for word the same, except for addition got changed for subtraction. It got substituted. Get it? Okay. Anyway, symbols. Abby. No. Okay. For any numbers A, B, and C, so we have different numbers A, B, and C. These variables represent numbers. If A is equal to B, then A minus C is going to be equal to B minus C. So if we take those two numbers that were already equal, and we subtract the same C from both sides, then we're going to have a true equation still. Okay, so make sure you write that in that box there. Make sure you write that in that box there.
I wrote that in the box there.
Hey, dope. All right. So an example. Abby, give me a number.
12.
12. 12 is equal to 12. I think that's pretty accurate, don't you guys? Alrighty. Okay, Jocelyn, give me another number. 8, okay. So if I take 12 and I subtract 8, and I take it on the other side and I do the same thing, I take both sides and I'm going to subtract 8 from both sides, the same number. What's 12 minus 8 on the left side? Okay, what's 12 minus 8 on the right side? Oh, it didn't change. Okay, cool. So 4 is equal to 4. Is that still true? Yeah, so we started with the true equation, 12 equals 12. We subtracted the same thing from both sides, 8. We end up with the true equation, 4 equals 4. That's what the property of subtraction property of equality is saying. Questions on that example? Alrighty. Yes.
Why would you even go through all those steps to do 4 equals 4 when you could just do it and get it all focused?
It's just a way of trying to show, hey, this is always true. Here's an example just to show you it's true. You don't have to go through all those steps. It's just showing you, here is why it works. But now that we know how it works, we can go through less steps. All right, so solve the equations. K plus 63 equals 92. K plus 63 equals 92. Okay, Isaac, what's happening with our variable K? It's being added. What's the opposite of addition, guys? Subtraction. What are we going to subtract by?
63.
63. We're going to want to subtract both sides by 63 because we want to isolate our variable K. We want to undo the addition of 63. We're going to subtract 63. But according to our subtraction property of equality, we have to do it from both sides of the equal sign. On the left side, what's 63 minus itself?
0.
0. We don't have to worry about it. You don't have to write K plus 0. Okay. K is equal to, well, 92 minus 63. If you don't know that off the top of your head, you can feel free to do that off to the side. But anyone know what it might be?
29.
It is 29. Okay. Anybody in here watch New Girl? Raise your hand if you watch New Girl. Okay. You might get this or not. Okay. 29. Okay. Schmidt. Okay. On his birthday, first season. Okay. 29. Okay. I made that joke for 3 years. I've had one person now get it. Thank you. Okay. So it's been a rough time. Abby, did you get it? Yeah, it's a pretty good show. Anyway, so K is equal to 29. Okay. So it's like somebody just responded to your really long text. Okay. You guys can check your solution as well on this one. That was supposed to be a joke, but nobody laughed. 29 plus 63 equals 92. Does 29 plus 63 equal 92? Yeah, 92 does equal 92. Boop, it checks out. Questions on that one? All right, I want you guys to try number 2. When you have it or have questions, raise your hand. Number 2, when you have it or have questions, raise your hand. So on number 2, 7 is equal to 42 plus t. What is happening with our variable t?
Adding.
We're adding 42. It's adding with 42. How do we undo addition? Subtraction, okay? And let's double check here. Subtract 42 on both sides. What is 42 minus itself?
0.
0. That's what we need to happen, right? We need that to go away from this side. So we're going to subtract 42 to make it go to 0. And so to do that, we have to subtract 42 from both sides. Now on the left side, 7 minus 42. These are different signs. So we can subtract the 2. 42 minus 7 is 35. But which number is bigger? Negative. So it's a negative 35 equals just t. Negative 35 equals t. Okay? If we go back and check our work just to make sure, if we weren't sure if it's supposed to be positive or negative, or whether we got the right number, check our work. 7 equals 42 plus a negative 35. 42 plus negative 35, what's that? It is 7. It checks out. I want you guys to try number 3. It is a negative, okay? So if you got a positive and you go back and check your work, it's not going to work out. You're going to get 7 is equal to 77. Not the same thing. Okay? So once you have number 3 or have questions on number 3, raise your hand. So as we went through this one, 21 plus q, 21 plus q is equal to negative 18. What's happening with our variable q?
Being added.
It's being added. How do we undo that? Subtract 21 from both sides. 91 minus itself is 0. Q is equal to what? Negative 39. Be careful. It does have to be negative 39. Positive 39 is not the same thing. Question on that one. Okay. Now, on your guys' homework and on tests and stuff, I don't make you check your work. I don't make you check it. But I just want to teach you guys how to, so that way if you want, you can. Because it's a free way to know whether or not you did it right before you even turn in something, okay? Questions on that? Dope. Okay, you guys are great. Okay, let's continue on. We're legit almost done with these notes here, okay? So let's flip the page over. 11:30. You have a lot of time. Alrighty. We got some variables and fractions. Fractions. I'm completely lost. I'm miserable. I don't know how to do it. Just kidding. We're going to be fine. Don't panic. Okay. Y plus 4/5 equals 2/3. Y plus 4/5 equals 2/3. Okay. So, what's happening with our variable? We're adding. Don't panic. What do we do when we add? When we have adding with our variable? We subtract by whatever's there. So what are we going to subtract by? 4/5. We're going to subtract by 4/5 just like we would normally. Okay. 4/5 minus itself is what? 0. Anything minus itself is 0. So we just have y is equal to, wait, can we add and subtract those fractions right now? We need to get common denominators first. So let's just write it out first. 2/3 minus 4/5. And I heard a couple people saying our common denominator will be 15. That is the lowest common multiple that you could have, okay? That's the lowest number that they both can multiply to is 15. Okay, you could go higher. Okay, you could go to 45 or 30, but that'd be giving yourself more work than necessary, but you could do it. Okay, could do that. So how are we going to get that first fraction to have a denominator 15, Courtney?
You take 3 times 5, and then you take 2 times 5, whatever you did the bottom and the top.
Yep, we have to multiply the top and the bottom by 5. So I'm going to write 5 times on the top and the bottom. I'm going to do it in different colors so you guys can see what I'm doing there. So now I'm going to have y is equal to 10 over 15 minus, okay, what do I have to do to the second fraction to get the denominator to 15? Multiply the top and the bottom by 3. Okay, but be careful, we do have to do it to both. Okay, top and the bottom by 3 there. Okay, so I'm going to have 4 times 3 is 12 over 15. Now we have common denominators, and we can solve. So then as you can see, I kind of ran out of room. You guys might run out of room too. If that's what happens, here's what I do. You think someone might be able to follow that? I hope so. Okay, I hope so. Okay, so what do I do now to subtract these fractions?
To subtract.
So just subtract, what's that mean? Am I subtracting the bottoms or the tops?
The top.
Just the numerator, just the top. Okay, what's 10 minus 12? What kind of 2? Negative 2. What do I do with the denominator? It's the same thing. It's still just 15. We just went to all this work to get the same denominator. Let's keep it there. And I actually miswrote this. I need to put y is equal to negative 2 over 15. Is y by itself? Yeah. So did having a fraction change what the overall of what we did there? No. Okay, it just made us add in a step. It made us add in a step of having to get common denominators. But overall, we still looked and said, what's happening with our variable? How do we undo that? Okay, so the overall of that is not any different. So don't let that dismay you, okay? Don't get freaked out by fractions. Questions on number 1 at all? All right, number 2. 1 is equal to x plus 0.356. Are we going to freak out over decimals? Nope. We're going to stay calm. We're going to figure this out, okay? So, what do you think you're going to do here?
Subtract 0.35.
Yeah, we're going to subtract 0.356. We're currently adding it, so we're going to do the opposite. From both sides. On the right side, 0.356 minus itself is just 0, so we're left with x, okay? On the left side, we might not know that off the top of our head, okay? We can write that off to the side. I'm going to do a different color off to the side just so we can see it better. Let's say I do 1 minus 0.356. Okay, actually, I need to write that a little bit lower so you guys can see what I'm doing. Okay? Now, what am I going to have to do with this 1? Yeah, add the decimal, 0, 0, 0. And notice I lined up the decimals before I started, right? Okay? And I'm going to have to borrow, won't I? Because I can't do 0 minus 6. But I can't borrow from the 0 next to or the 0 next to that. So I'm going to have to borrow all the way from the 1. The 1's going to become a 0. The 0 next to it will become a 10. But that has to become a 9 now. And the 0 next to that becomes a 10. But that has to become a 9 now. And the 0 at the end becomes a 10. Does that process make sense to everyone? Give me a thumbs up if that was good. Give me a thumbs down if that was not good. Okay, thumbs up if you're good with that. Thumbs down if you're not. All right, thank you. Okay. So, 10 minus 6 is? 9 minus 5? 9 minus 3? Drop the decimal. 0 minus 0? 0. So, x is 0.644. And truthfully, you don't even have to have that 0 in front of the decimal. If you want to just put 0.644, I'm cool with that. Just make sure your decimal is obvious. Okay. Just make sure we can tell the decimals there. Any questions on that one? And we can check our work on these too. Okay. Once again, I'm just saying I'm not going to make you guys check work. I just want to let you know it is an option. All right. Number 3. A plus 1 is equal to 2 over 7. A plus 1 is equal to 2 over 7. I want you to try this one on your own. When you have it or have questions, raise your hand. So A plus 1 is equal to 2 over 7. So as I walked around, what I saw was we knew, hey, we need to subtract 1. We knew that. 1 minus 1 is 0. A is now 2 over 7 minus 1. We're like, okay, well, what do we do here? We need common denominators. What's going to be our common denominator on this one? 7. Multiply the top by 7 and 7. Do we need to multiply the first fraction at all? No, we don't. So now we have A is equal to 2 over 7 minus 7 over 7. So we subtract the numerators. 2 minus 7 is?
-5.
Yeah, so we have negative 5 over 7. The fraction stays the same. Okay, the denominator stays the same. A is negative 5 over 7. Okay, way to think about this, about what to do with the denominator. Because some of us are like, okay, do we change the denominator? What happens there? Okay, let's think about it this way. Pizza. Okay, 8 slices. Okay, let's say the pizza has, a pizza will have 8 slices in it. A lot of them do, not all of them, but a lot of them do. Okay, you have a pizza with 8 slices. So you start out with 8/8, correct? You start out with 8/8 of the pizza. Okay, so you have 8/8 of this pizza. Okay, and you don't have to draw this. I'm going to just draw this on here real quick though. Okay, you have this pizza. You have 8/8. Let's say I subtract 2/8. Okay, actually I subtract 3/8. We eat them. How much do we have left? 5 eighths, so they're still eighths. Okay, so it's not 5 whole. That'd be awesome because then you have 5 whole pizzas. But that's not what happens. You still have 5 eighths of your pizza. You have 5 slices, which are eighths. Does that make more sense as to why the denominator has to stay the same? Because how many parts it was originally split in didn't change. Just how many of them you have, the numerator, is what changed. All right. So looking at the next example here, this is kind of like one of those word problems that we had before. You guys remember how chapter 1, the very first section, we practiced taking words and putting them into math, right? Okay, we took these verbal expressions, made them algebra expressions. We're going to do the same thing. Okay, so 14 more than a number is equal to 27. 14 more than a number is equal to 27. Find the number. I want you guys to try writing this equation. I want you to try writing this equation, okay? Okay, in a second. So just first, let's write the equation. 14 more than a number is equal to 27. I want to give everyone an opportunity to try writing this equation. If you've already done it, thank you. Please wait patiently for a moment. Not yet. We're going to solve it in a second, though, together. All right, raise your hand if you want to share with me what you got for your equation, okay? Let's go with Alice. X plus 14 equals 27. That would work. Did anybody have anything slightly different? Courtney?
I have 14 plus X.
14 plus X. Does it matter the order we add them in? Nope. Okay, so whether you have 14 plus or X plus, either one first, it's okay. Very good. Any questions on how we set up the equation? All right, we know how to solve this one now. What do we do? Subtract 14. Very good. 14 minus itself is 0. X is equal to whatever 27 minus 14 is. What is that? 13. Could we go back and check our work if we wanted?
No.
Definitely. Do we have to? No. Okay. But if you have time on a test, it might be worth it. Okay. Questions on that? All right. Number 5, the very last one. The Washington Monument in Washington, D.C. You guys know what that is? Okay. Okay. Oh, cool. Okay. It was built in 2 phases. Okay. It was built in 2 phases. It's actually true. It was. Okay. During the first phase, the monument was built to a height of 152 feet. During the second phase, additional construction resulted in the monument's final height of 555 feet. How much of the monument was added during the second construction phase? Good morning. Write an equation to solve the problem. That's a lot of words, isn't it? Okay, do we think we might need all that information? No, okay. Something I like to do, have we talked about this in here yet? Okay, I really like to underline key information. A lot of it happens to be numbers. I like to underline key information, okay? This is a great tip when it comes to test taking, okay, and homework, especially on ACT, but it also works on other things. Is write down key information or underline or highlight somehow key information to point out. Because you don't need all of this. A lot of it's fluff. Raise your hand if you see a piece of key information that you think we need. Raise your hand if you see a piece of key information that you think, you know what, we might need that. Okay, Jaden? The numbers, okay? So during the first phase, built to a height of 152 feet, final height of 555 feet. Probably pretty important in math class, the numbers, okay? Abby? No, what about it? We had a second phase.
That resulted in.
Okay, second phase resulted in. Okay, what's the resulted in probably going to be? What do we think that's probably going to be in math? Resulted in? An equal sign. Okay, that's probably an equal sign. Okay, that's probably pretty important. Okay, during the second phase, we had additional construction that resulted in. Is that what you're going to say, Courtney?
Yeah.
Okay, second phase, we had addition. Is that what we're going to say too, Jocelyn? Awesome. We're going to have additional construction. That's probably a key word. Words like additional, or less, or more, or of, or resulted in, or equals, or gets to, totals, things like that. Okay? What's another piece of key information? I think I see probably, arguably 1 or 2 more, depending on how you look at it. Okay, Alice? Okay, the final height was 555. It's probably pretty important to know that that number is the final height. So not only do you want to pull out the numbers, you want to say, what about that number? Okay? I see one more piece of information that I think might be important. Okay, Abby, Simmonsma, actually. Okay, write an equation to solve the problem. Okay, what we're trying to do Okay, that's important. That's not actually what I was going for, but I do agree with you. That's important. Okay. Okay. Abby Dasher.
Would it be how much was added during the second construction?
How much was added? That's what we're trying to find. Is it important to know what we're trying to find?
Yeah.
I think so. Okay. Now, did we highlight absolutely everything in this paragraph? No, okay? There's a lot of fluff there, isn't there? We didn't need the rest of that. We don't really need it. Okay, it gives us context on what's happening, but when we get down to it, we don't need it to help our equation. Okay, we know we're writing an equation, though. So, can anyone help me try and write an equation for this? Okay, Courtney, what are you thinking?
152 plus x equals 555.
Okay, and explain your reasoning of why you did that.
So the first phase, they had a height of 152.
Okay,
That's what we started with.
okay,
And then in the second, in the final, they had 555, which is what the total was.
okay.
And they're asking how much was added during the second phase. So you don't know that number.
Okay.
So it's plus x.
Yeah, so we don't know that number, so it's plus x. Okay, Elijah, what are you
I
thinking?
did 555 minus x equals 152.
Okay, another way of thinking about this. 555 minus x equals 152. Explain your reasoning.
Because you're basically subtracting whatever the number is to get to the answer out.
Okay, so if we started with 555, if we take away what we did during the second part, what should we be left with?
How much they had in the first.
How much they had in the first place. Okay, both these equations work. Both of these equations are true. Okay, they're just different ways of looking at it, but both are true. Okay, and if we look at this, if we look at the left equation compared to the right equation, what happens if I add x to both sides? And we know I can add x to both sides, right? These x's would go to 0, and I get 555 is equal to what? 152 plus x. So are these equations really the same thing? Yeah, we just moved the x around. But the equations are the same. So I'm going to work on solving the second one. Elijah, feel free to work on solving the one, or I'm going to solve the first one. Elijah, feel free to solve it the way you did it, though. I guarantee we'll get the same thing if we do it correctly. Okay? Yes.
Where do I put my signature?
You can just leave blank. Okay? Can I see it? Oh. Good luck. Okay.
Can I go this way?
Yeah. Oh, yeah. During non-passing period. Oh, okay. She's nice. Anyway.
She says good morning at the door, and I say good morning and walk away.
Hey, Miss Caniglia.
I cannot
All right,
say
Haven.
her name.
Okay. 152 plus x equals 555. How would we solve this equation? Haven, how would we solve this equation? Okay.
You add.
Okay, what's happening with our variable x, Haven?
What'd you say?
What's happening with our variable x? We're doing what operation? Adding. How do we undo adding? Subtraction. We're undoing it because we want to get it by itself. So what are we going to subtract by? Oh, bam. And you're saying you don't know. All right, we're going to do it on both sides because we got to keep it equal. Okay. What's 152 minus itself?
100.
Not quite. 152.
0.
0. It's gone. X is equal to whatever 555 minus 152 is. What is 555 minus 152?
403.
403. Is that what you had, Jaden? Awesome. 403 ostriches. 403 eggs. 403 feet. Labels are important.
I thought you were just saying.
Oh.
No.
I mean,
Okay.
it's not that hard, but
It's not that bad.
All right, sure. Okay.
How about
So on the front,
on the backside?
on the front, you're going to do all of them. But on the back, just do the evens.
Wait, so what?
On the front, you'll do all of them. But on the back, you'll just do the evens.
When is this due?
Okay? It's due next class, yep.
When's my
Wednesday.